All right, good afternoon. Welcome to the webinar on Systems Manager and Patch Management. Today we're going to try to walk you through a number of Systems Manager principles, some of the capabilities that are in Systems Manager, and talk about patch management concepts. Hopefully by the end of this webinar, you'll be able to use patch baselines to include rules for automatically approving patches within days of their release, and provide a list of approved rejected patches. You'll also be able to leverage patch groups to organize instances into groups for patching based on your environments, roles, other factors. And lastly, we'll learn how to install patches on a regular basis by scheduling using maintenance windows and run command tasks, as well as monitoring the compliance of those resources. So according to a recent study published by the Ponemon Institute in collaboration with ServiceNow, they found that nearly 48% of organizations suffered at least one data breach in the last 2 years. And most of those breach firms, about 57% actually, attributed the incident to the successful exploitation of a vulnerability for which a patch was available at the time of the incident but was not applied. Furthermore, 1 in 3 of those breached actually knew they were vulnerable before they were breached. So improving vulnerability response and management procedures can dramatically reduce the risk of compromise and data exposure. So consistent and rapid deployment of security patches is a pivotal step in this process, and we think AWS Systems Manager is a great way to help you with that. So let's unpack how we can leverage AWS Systems Manager to address this very important and very real issue of consistent and rapid deployment of security updates at scale by first reviewing what AWS Systems Manager is and the capabilities it provides. So AWS Systems Manager seeks to provide operational visibility and control by helping you to group, visualize, and act. Grouping means the ability to create groups of resources across different AWS services to reflect an application stack in our environment. And one of the areas that this differs from traditional resource groups now is that we can group other resources besides just EC2 instances. So everything from S3 buckets, EC2 instances, security groups, all the things that make up your application stack can now be grouped together, and you can reflect that inside Systems Manager as well. Visualizations allow us to centralize that operational data from all these different AWS services into a single pane of glass and be able to view things like patch compliance, audit data, all sorts of other things. Acting is the intrinsic capabilities that existed in EC2 Systems Manager before. So these are all the things like run command and state manager, maintenance windows, patch manager, all the different capabilities that are intrinsic to Systems Manager, that we're going to learn how to leverage these things together in order to build a coherent patching strategy. And some important call-outs here is that Systems Manager is both cross-platform, so we can support things like Windows and Linux instances. You can also manage your AWS instances as well as on-premise instances in your data centers or in other cloud providers for that matter. And it natively works with other AWS services. As we've already mentioned, there are tons of integrations into other services, things like AWS Config, the ability to pull resource groups across different services. So a very powerful set of tools that we think you can use to build a very cohesive management strategy. So with that, now that we've had a brief introduction to Systems Manager and the ecosystem, let's take a closer look at Patch Manager, some of the core concepts we'll need to understand to be successful. And with that, I'm going to turn it over to my colleague, Sohib.
So let's look into the Patch Manager. So what is basically the Patch Manager? So Patch Manager allows you to automate the process of patching managed instances, both EC2 instances or your on-premises instances, or really any virtual machine that is running AWS Systems Manager agent. And then you can basically deploy security-related updates using the Patch Manager. So for Linux-based instances, you can also install patches for non-security updates. Patch Manager leverages the intrinsic capabilities of AWS Systems Manager, like run command, documents, maintenance windows, to enable remediation of operating system vulnerabilities in a safe and scalable fashion. So Patch Manager also allows you to automate the approval of patches using what we call patch baselines that we will cover in the later portion of the webinar. It also allows you to use maintenance windows to deploy the patches using a schedule of your own to reduce the impact on your server availability. And then once the patches are deployed, you can use compliance reporting for audit and remediation. That is also available through Patch Manager. So the overall workflow when you're deploying patches using Patch Manager looks something like what you can see in the diagram. So you would define a maintenance windows that would basically define a schedule when you want to deploy your patches. And then using System Manager capability called Run command, you will use or you'll execute the AWS Run Patch Baseline to deploy patches against either the ungrouped targets or ungrouped instances or servers, or you can also group them together using what we call patch group that we will basically cover in the later section. And then in this way, you'll be able to automate your entire patch deployment workflow. With this, we'll look into how Patch Manager basically select patches. So when it comes to the patch selection, the primary focus of Patch Manager is installing operating system security-related updates on instances. By default, Patch Manager does not install all the available patches, but rather a small set of patches focused on security. Patch Manager uses different processes to evaluate which patches should be present on Windows managed instances versus Linux managed instance. So, and we'll look into both of these approaches in the next slide. So for Windows patches, Patch Manager uses a single source repository and it uses Windows update source cabinet file to generate a snapshot of a patch baseline. Patch Manager downloads this file regularly from Microsoft and uses it to update the set of patches available for Windows instances. And it only takes into account the patches which are being identified as security patches by Microsoft. As the information is processed in this file, Patch Manager also removes updates that have been replaced by later updates. Therefore, only the most recent update is displayed and made available for installation. For Windows patching, Systems Manager evaluates patch baselines, rules, and list of approved and rejected patches directly in the service. It can do so because Windows patches are pulled from a single repository. For Linux, System Manager uses multiple pre-configured repositories on each instance. For example, for Amazon Linux, Red Hat, Enterprise Linux, CentOS, Systems Manager Patch Manager uses Yum, which actually uses the concept of an update notice. An update notice is simply a collection of packages that fix a specific problem. All the packages that are in an update notice are considered security by Patch Manager because the individual packages are not given any classification or severity. Similarly, for Ubuntu systems, Systems Manager performs the equivalent of a sudo apt get update command. Packages are then filtered from a codename security repository. For example, trusty-security in case of Ubuntu Server 14. And similarly, it uses locally pre-configured repositories for the other Linux distributions. So for Linux patching, Systems Manager evaluates patch baseline rules and list of approved and rejected patches on each managed instance versus within the service for Windows. System Manager must evaluate patching on each instance because the service retrieves a list of known patches and updates from the repositories that are configured on the instance. For Linux, Systems Manager also has the capability so that it can use alternative patch source repositories that you can use to install patches that are not security related. So now that we have had a brief introduction to Systems Manager ecosystem, let's take a closer look at the Patch Manager and some of the core concepts we'll need to understand to be successful.
Thanks, Suhaib. So the first concept that we want to really dive into here is patch baselines. And so a patch baseline defines which patches are approved for installation on your instances. So this is where we can specify approved or rejected patches one by one. So if we want to have a white list or a black list of approved patches, we can do that. You can also create auto approval rules to specify that certain types of updates, for example, critical updates, should be automatically approved. The rejected list, it's important to note, overrides both rules and the approval list. So if we explicitly reject or blacklist an update, that will never be overridden by any sort of auto approval rules that we put in place. Another important concept to consider here is that a patch is installed only on an instance only if it applies to the software that's on the instance, even if that patch has otherwise been approved for the instance. So, for example, if we have a patch that's specific to an Nginx web server, but a Linux instance doesn't have that particular package installed, then the patch will just be skipped and it'll be not applicable. So, Systems Manager also provides sort of predefined patch baselines for each of the operating systems supported by Patch Manager. So everything from Amazon Linux, CentOS, Windows, and all the other specifics that we've covered. So you can use these baselines as they are currently configured. They're not customizable. Or you can create your own patch baselines if you want greater control over which patches are approved or rejected for your environment. An instance can only have one patch baseline assigned to it. So you have to decide, whether the default baselines make sense, or if you want to customize those, you can do so, but you can't use both. If you create your own patch baseline, you can choose which patches to auto-approve by using the following categories: operating system, product name, classification, or severity. So you can really build auto-approval rules that give you a lot of flexibility over how different types of patches are automatically approved and when the duration is, or how long you wait before they're approved. For each auto approval rule that you create, you can specify an auto approval delay. So this delay is the number of days to wait after the patch is released before the patch is automatically approved for deployment. So if a Linux repository doesn't provide release date information for packages, Systems Manager treats the auto approval delay as having a value of 0. So it's important to note some different package repositories don't have that date value. So in those cases, we'll just treat that as a 0 value. Another important concept here to note around patch baselines, and something that we think is pretty powerful, is the ability to use multiple patch baselines with different auto approval delays. So, I mentioned that an instance can't have more than one patch baseline attached to it, but what we can do is assign different patch baselines to different environments. So this multi-patching strategy really comes into play from environment's perspective. So if we look at a staging environment and a production environment, for example, we might be more aggressive in staging and auto-approve those patches quite quickly, but have a more conservative delay in production, so that it gives us plenty of time to test those patches in non-prod before they get into production. So this would be a good way for you to test your patches before obviously pushing them out to production. So in this, we're going to dive into a bit of a demo in the console just to start building on some of these concepts in a live manner. So you just go ahead and switch over to the console here. And so what we're going to do is just take a look at what it takes to build a patch baseline. We'll take a look at the different ones that are available to you as a default set of baselines, as well as sort of the customized approach that you can take as well. So as we mentioned, all of the patch lines here that are default at the top are the ones that Amazon provided, and again, you can't modify these. These default patch baselines are specific to an operating system, so whether they be Windows or Ubuntu or CentOS. And in the same way, we can build our own custom baselines for each of these operating system types. Something to note too, it's also possible to override the default baseline. So, if you build a custom baseline and you want to make that new baseline your default for that operating system, you can certainly do that as well. So if we were to take a look at, creating a new baseline, essentially all we're really going to look at here is selecting the type of operating system that the baseline applies to, so whether that be Windows or Amazon Linux or CentOS or something like that, and then defining the approval rules that go along with it. So in this case, we're going to build a patch baseline for Windows, and we're going to assign this the production environment here. And as we get further into this, so he will talk about patch groups and how we group these things together, and we'll start building these things together, and you'll see how they all fit together. But basically, we're starting to build out a rule here that says that any Windows Server 2016 critical or security updates that are released and that are assigned the severity of critical or important, go ahead and auto-approve those 15 days after their release. And here we're able to also set a value that says if an instance fails this approval rule or busts the compliance rule that we've set here, we can assign a compliance value to that. So whether we want to consider that a critical situation or reduce that severity. And then, as we talked about before, this is the area where we get to start defining overrides or explicit approvals and denials. So in this case, we can actually approve patches explicitly one by one, and we can also blacklist or reject those patches one by one as well. So an interesting thing here is that a lot of times organizations might have an issue with an update that was released and need to prevent that from getting deployed. This is a fantastic way to be able to come in here quickly into a console and say that you want to reject that patch from any further deployments, and at least if you found an issue and say example non-prod, come into your production and blacklist that patch until you can sort out what the problem is. So. All right. Now, with that being said, I'm going to go ahead and switch back to the presentation and hand it back over to Soheeb. And we're going to talk about, patch groups and how we can organize these things to start building out that multi-patch strategy that we were just discussing.
Thank you, Eric. So let's now talk about patch groups. So first, what are the patch groups? So a patch group is an optional means of organizing your instances for patching. For example, you can create patch groups for different operating systems like Linux or Windows, different environments like development, test, and production, or different server functions like, you can create a patch group for web servers, file servers, or database servers. And then you can also create primary and secondary failover cluster groupings if you want to. Unlike other tagging scenarios across System Manager, a patch group must be defined with the tag key value of patch group. You can basically register your patch groups with the patch baseline that Eric described in the previous section. By registering your instances to a patch group with a patch baseline, you ensure that the correct patches are installed during the patch execution. After that, you can create a maintenance window and you can start deploying your patches. And Eric will speak more about maintenance windows in the next section. So one thing to notice is that an instance can only be in one patch group. If an instance isn't configured for any patch group, the system automatically uses the currently configured default patch baseline based on the operating system of the instance or managed instance. So let's now dive into how you can actually create patch groups in the Systems Manager console. So we are again in the Systems Manager console. We'll go back to, actually I'll cancel the previous demo and we'll go back to the main Patch Manager page. And here you can again see all the patch baselines, default ones, and the custom created patch baselines, which you can see here. So I'll just select the first one, and then I'll go into the actions and I'll select modify patch groups. So here you will come and you will put any value for your patch group key value pair. So in this case, I'll put production. Actually, I'll select the production windows. So now I would have to go and tag my instances or servers with this tag. So I'll go back to EC2 where my servers are running, and I can, and from my running instances, I will select production Windows instance, which I pre-configured, and I'll go to tags, and then I can, and you can see here that I've already tagged my instance as patch group production Windows. So this is how you will create a patch group and add that key value pair to your EC2 instance or your servers. Switching back over to the presentation. What we have done so far, we looked into patch baseline, we looked into how you can create, what is a patch group and how you can create patch groups and how you can organize your instances in a patch group. So after you configure a patch baseline and optionally you have attached a patch group to it, you can apply patches to your instance by using a maintenance window. So in the next section, Eric is going to walk you through what maintenance windows are.
Thanks, Sahib. So yeah, now that we've built on that concept here, we're going to talk about how we can actually schedule tasks. So what we've done now is been able to group instances into logical groups, whether they be by environment or type. We've built baselines, and so now we're going to actually do the meat and potatoes of actually getting these tasks scheduled. So an important thing to note is that after Systems Manager installs any patches, it has to reboot the instance. And so the reboot is required to make sure that patches are installed correctly and to ensure that the system didn't leave the instance in a sort of a potentially bad state. So what we want to do with maintenance windows is kind of reduce the impact on server availability. So we can specify a time to perform those patching processes so that it doesn't interrupt business operations. And as we get into this, we're going to talk a little bit about maintenance windows, and then we'll also talk about some of the underlying components that the tasks require, and discuss how those things fit together and how we can kind of control the rate of the deployment and concurrency and things like that. So specifically, a maintenance window is going to have things like a schedule, a duration. It's going to have a set of registered targets and a set of registered tasks. So we've already talked about how we grouped instances by patch groups. So those are our dynamic ability to target those instances by group. And then we're going to set up the other criteria, like how long the maintenance window should last, and sort of how we want to proceed through the set of tasks. So to understand how that all works, we need to get into a little bit of the actual task logic itself. So we need to understand a bit about run command, which is an intrinsic capability that's built into Systems Manager, as well as the Systems Manager document called AWS Run Patch Baseline, which makes sort of all of this possible. So run command enables you to automate common administrative tasks and perform ad hoc configuration changes at scale. So Patch Manager leverages run command to enable the deployment of security updates to manage instances. So this is how we actually get the deployment. And something to note is that we can control the rate of deployment by specifying the maximum number of targets allowed to run in parallel. So we can either specify that as an explicit number, so no more than 10 instances at a time, or as a percentage of the target, so something like 10% of instances or 50% of instances can run at a time. You can also specify an error threshold within here as well. So that specifies the number of errors that are allowed before the system stops running the automation on additional targets. You can specify this as either an absolute number of errors, for example, 10, or a percentage of the target set, for example, 10% of the target. So this is a good way so we can both control the rate of execution as well as we can also stop running this any further if we start experiencing errors. So this lets us at least stop propagating a problem across the fleet if we run into a problem deploying the patch. So as we talked about, Systems Manager, as most people will be aware, uses the concept of documents to control automation tasks. So the primary document that we use for patch deployment is a document that AWS provides to you called AWS Run Patch Baseline. So this document supports executing patch operations on both Windows and Linux, so it's cross-platform. And the document will perform the appropriate actions for each platform. On Windows instances, the AWS Run Patch Baseline document downloads and invokes a PowerShell module, which in turn downloads a snapshot of the patch baseline that applies to the instance. This patch baseline snapshot is then passed to the Windows Update API, which controls downloading and installing the approved patches as appropriate. So it's important to note here on Windows that Systems Manager still leverages the Windows Update API. So when we're doing patch installation, we will respect all of the Windows Update API configuration settings that exist on the instance. So for example, if you're used to using like a WSUS server inside your organization, and you have your managed instances configured to point to that WSUS repository rather than the internet, those instances will pull from there, and they can still use Systems Manager to trigger those updates, just like you would with any other solution. On Linux instances, the AWS Run Patch Baseline document invokes a Python module, which in turn downloads a snapshot of the patch baseline that applies to the instance. This patch baseline snapshot uses the defined rules and list of approved and blocked patches to drive the appropriate package manager for each instance type. So as Soheeb mentioned earlier, this is the situation where with the Windows environment, we can get that snapshot and generate that data inside the Systems Manager service itself. And then on the Linux side, we actually have to evaluate on each managed instance themselves because of the fact that they could be using a plethora of update sources. This document also includes an operation parameter which provides the ability to run in a scan or install mode. So in scan mode, the document determines the patch compliance state of the instance and reports this information back to Patch Manager. Scan does not prompt updates to be installed or instances to be rebooted. In install mode, the document will attempt to install the approved and applicable updates that are missing from the instance. So whenever an update is installed on an instance, as we mentioned before, the instance must be rebooted to ensure the update is installed and active and that we don't leave the system in an unhealthy state. So, this is the default document that we use for patch management, but this is certainly not, where you have to stop. So a lot of organizations find that they might have custom requirements that they need to implement inside of their patch management lifecycle, whether that be detaching instances from a load balancer or all sorts of different things that they might want to do. So this is really a foundational document on which you could build your patch management and certainly run your entire patch management framework on. Or if you find that you need to customize it, these documents are a great starting place to build on. So we're going to switch back into a demo and go into looking at what it takes to build that maintenance window and start automating the tasks that we've talked about. So what we've got here are a few custom maintenance windows that we've built. And if we look at what we're doing here, essentially, as we talked about before, we have groups of instances logically called patch groups, right? And so what we've done is build two patch groups based on environment, one being production and one being stage. So this simulates the multi-patching strategy that we talked about earlier. So what we're going to do here is build a maintenance window that will patch all of our production servers and all of our staging servers cross-platform, whether it be Linux or Windows, and then sort of set up the controls around that. So obviously you can schedule a maintenance window that's its primary goal here. And we can do this in a number of different ways. We can set them up to cycle just like any other cron task. So it can be every 30 minutes, every 15 minutes, or specific days, specific hours within those days, those types of things. So you can get very granular with this, and you can actually specify your own specific cron expressions. And then what we want to do is set a duration, so the maximum amount of time that this maintenance window should be valid. So whether that's 4 hours or 12 or whatever it is, up to a maximum of 24 hours. And then this last bit here, which is stop initiating tasks, this is a control which we can put in place to say that if we are getting close to the end of that window, we don't want to initiate any more tasks. So if things have been taking a while to run, for example, a bunch of instances that have a lot of patches, we certainly don't want to get really close to that end and then start initiating tasks on instances and then have them sort of rebooting outside of the maintenance window. So this is just a way that we can make sure that we have a safety net to keep us from encroaching on that maintenance window. And then within a maintenance window, once we've defined sort of when it should run and all the controls around that, what we really want to do is specify a set of targets. So these are where we can actually point a maintenance window to a group of instances. And so let's take a look at what that looks like. So here we're targeting the production Windows servers in our environment. And we're doing that based on the patch groups that Soheeb built earlier, which again is just an EC2 instance tag called patch group, and then whatever the patch group is named. So this is dynamic. So as instances come and go into that patch group, as long as they're tagged properly, this target, when it runs, will find those instances. We don't have to explicitly keep a list of EC2 instances or managed instances. And then we've done the same thing again for Linux servers. So again, the exact same process here. Again, we're just changing the patch group to production Linux in this case. So this allows us to build multiple targets into a maintenance window so that we can say these are the entirety of our production environment. Now you might choose to do, as Soheeb mentioned, if you have failover clusters, you might choose to do these in different maintenance windows. So you do the primary and secondaries, all sorts of different options. But this really gives you a ton of flexibility to control what you target and when. And then lastly, within this maintenance window, we're going to tell it to run some tasks. So as we mentioned before, we have the AWS Run Patch Baseline document. And this document is, uses run command to execute the task in question here. So all we're doing is saying patch production servers. Again, we're going to hit Linux and Windows for production in this case. We're going to specify the documents. In this case, right? So we've got this Amazon published document called Run Patch Baseline. Again, it's capable of running against both Windows and Linux, so it's cross-platform. It's possible to register multiple tasks and then assign priorities, so you can actually orchestrate a workflow that says this must be ran on the instances before they patch. So for example, if you need to gracefully exit a process or do some sort of pre-work, you can certainly do that as well. Without actually having to modify this document. So it's possible to chain things together as well and assign priorities. And then within targets, we're actually specifying the patch groups that we mentioned before. So we have these 2 targets. Again, these are dynamic. So as instances come and go, we will actually hit those in this maintenance window. And then this is what we were discussing before, which is the ability to finally control both the concurrency and rate control as well as the error threshold. So in this case, we're saying that this is a rather aggressive concurrency setting, but we're saying that 50% or half of the environment can patch at the same time, but you should stop if you get a single error. So in this case, half the environment would be allowed to be patched at once. So this is maybe a bit aggressive for a production environment, but certainly up to you guys to decide what's best for your environment. Something to note here is that maintenance windows do require an IAM role. So you can either use a service linked role or a custom IAM role. Really just depends on whether or not you want to use some of the features here that we'll show you in just a second. So if you want the ability to use SNS notifications, for example, it'd be a situation where you wouldn't want to use the default service linked role. You might want to create a custom IAM role so that you can tie that into your SNS topics. But run command has this ability to send the output from every instance that it runs on. So when this maintenance window triggers the task, you'll get a task instantiation on each instance that's part of the target group. So what we want to do is be able to capture the output so we can debug or troubleshoot problems. So this is the ability for us to write that output to an S3 bucket so that we can go back and look at it later in its entirety. And then lastly, we can also tie this into an SNS topic as well, so you can trigger a topic notification based on an event type, so whether it's success or failure or any event change. So you can start writing automation around this as well, so you can do notifications or trigger some sort of a chat bot or all sorts of things, right? And this is the ability to change whether we're actually going to just scan or install those patches, and then define a timeout for how long those should be allowed to run on each instantiation. Okay, so now we've got our patch groups, we've got our baseline, we've got a maintenance window that's set up to do scheduled tasks for us. So what we're going to do now is sort of look at how we can monitor the patch compliance across our fleet. So turn this back over to Sahib to talk about sort of the patch compliance and the reporting piece.
Sure. So after you have used Patch Manager to install patches on your instances, compliance status information is immediately available to you in the console or in responses to set of AWS CLI commands or Systems Manager API actions. For each of the patch that is installed by the Patch Manager, one of the following compliance statuses are available to you. For example, if a patch was successfully installed by Patch Manager, you'll see the status as installed in the console or through the CLI or API action. Similarly, if the patch that was approved in the patch baseline, it could not be installed, it will show you the status as failed. Similarly, if the patch that was part of the patch baseline, it was installed, it was part of the baseline, but the service or the feature that uses the patch is not installed on the instance, it will show as not applicable. And similarly, you can see the other statuses as well. Apart from this, you can also assign your own compliance statuses to the installed patches on your instances or servers using the API provided by the System Manager. And you can also track the historical patch deployment by Systems Manager, Patch Manager, using our other service called AWS Config. And so, this shows that, Systems Manager is well integrated with other services in AWS ecosystem. So, and similarly, you can use CloudWatch events to trigger automated actions. Maybe, if you find that a particular patch was failed to install on your system, you can trigger a workflow to fix that. So all those options are available to you. So now we will jump back to System Manager console to actually show you how it looks like in action. So in Systems Manager console, you can see the compliance option here. You will select this to find the compliance status for installed patches. So here you can filter the compliance type based on patch. And then you can see, all the instances that have the compliance type as patch. So these are the instances where System Manager actually deployed patches. And you can see, we have pre-configured certain instances here. So you can see there the compliance status, the overall compliance status for the instance. For example, you can see compliant instances and non-compliant instances. So I'll select the compliant instance, and it will take me basically to the managed instance itself. And there I can select patch, and I can see information about individual patches. So you can identify patches using the patch ID, and then you can see, what was the status is associated with that installed patch. So I can see, these first two patches, the critical update, security update patches, they were installed, and then there are installed other patches which are the patches that the service that consume these patches are not actually running on the instance. And I can filter my patches or the status to find the status of the patches based on the classification. In this case, I can select, for example, critical updates, and I can see all the patches that are classified as critical updates, and I can find their state. Similarly, I can select or filter the patches that were installed based on their state. So if I want to see any failed patches that were not installed on the system, I can select this filter, and here I can see there were no instances that were failed to install on the instance. So so switching back, so this is how you can basically use the compliance reporting by Patch Manager, and you can then if you want to, you can take automated action. So this basically brings us to the end of our webinar. So in this webinar, we introduce you to Systems Manager. We introduce you to different different patch manager capabilities, how you can use those capabilities to build a patch deployment workflow, how you can organize your instances in patch groups, how you can use maintenance windows to schedule your patch deployment, and how then, once your patches are deployed, how you can use compliance reporting to remediate, any missing patches, or to take automated actions, or just use, Systems Manager console or APIs to find the patch statuses. So this brings us to the end of the webinar, and if you have any question, we are here to answer.